Welcome to an exploration of the largest land vehicles ever constructed by humankind. As we uncover the engineering feats demanded to design, build, and operate these modern marvels, be prepared to question what is possible using human ingenuity and technology. We will introduce you to 8 true titans that were sculpted from iron and steel on the fringes of believability. Join me now to discover how humanity has built the largest vehicles on Earth. This is the Bellas 75,710, the largest dump truck in operation today. Built by the Bellas manufacturer in Belarus, it represents the pinnacle of heavy-hauling vehicles. Standing over 16 feet tall and weighing in at an astonishing 557 metric tons when fully loaded, the 75,710 is truly a beast of burden. Its monstrous powertrain produces over 4,000 horsepower, generated by a mighty V16 diesel engine. With a hauling capacity of 400 tons per load, the Bellas can shift more material than 50 conventional trucks. This enables mining operations to maximize output from open-pit mines. Complex computer systems help the driver handle such an unwieldy vehicle, slowing it to a crawl when navigating tight areas. Tasked with the back-breaking work of supplying the world's endless demand for resources, machines like the Bellas 75,710 are modern marvels, pushing the boundaries of what's possible in heavy equipment. The Komatsu PNH2350 is an ultra-class mining shovel that pushes the limits of heavy equipment design. Standing 36 meters tall with a 75-meter boom and 24 cubic meter bucket, it is truly a giant amongst machinery. Powered by a 13,500 horsepower electric drive system, the PNH2350 boasts over 13 times the output of a large bulldozer. This immense power is required to swiftly load 330-ton trucks with overburden or raw ore. At an operating weight of over 4,500 tons, special measures must be taken to move this titan around the mine site. The machine rides on custom tracked undercarriage with shoes over 2 meters wide to prevent sinking into soil. Engineers utilized advanced robotics technology to make the complex 75-meter boom nimble and precise for its scale. Hydraulic pumps capable of moving 30,000 liters of fluid per minute actuate the shovel with astonishing speed and force. Despite its dramatic size, the PNH2350 maintains high efficiency by working autonomously via GPS and 3D designs of the mine plan. One machine can replace up to 6 conventional shovels in productivity around the clock. Komatsu's mining shovel pushes the very boundaries of heavy equipment design and size. As long as open-pit operations continue expanding to unprecedented depths and scales, machines like the PNH2350 will play a vital role excavating raw materials to support global industry. The Caterpillar 6090 FS represents the pinnacle of ultra-class mining trucks. Stretching 35 meters long and weighing over 568 tons when fully loaded, it is unmistakably a machine at the very limits of size and scale. Powered by a hopping 6,336 horsepower V16 diesel engine, the 6090 FS maintains its speed even while hauling record payloads. Its massive 18-speed transmission transfers all that energy from the engine through 10 drive tires spanning 5 meters wide. With a 395-ton payload capacity, each trip of the 6090 FS equals the work of over 25 conventional trucks. This allows mines to maximize output even from the deepest open pits. To maneuver such a giant, the 6090 FS relies on advanced electronic controls. Forward-facing cameras assist with wide turns on narrow haul roads high above the pit floor. Laser guidance keeps the truck precisely on grade for dumping material into the fleets of shovels below. Caterpillar's 6090 FS embodies the continual advancement in mining machinery size necessitated by depleting surface deposits. As open cast mines push the boundaries of grade and depth, these behemoths will remain on the cutting edge of heavy equipment capability. Future resources depend on today's engineering marvels, like the undisputed champion of ultra-heavy hauling, the Caterpillar 6090 FS mining truck. In the specialized field of super heavy lifting, none compare to the Liebherr or 13,000 crawler crane. Towering 315 feet over the job site, it is the tallest crane ever constructed for heavy transport and assembly tasks. Powered by a massive 3,000 horsepower prime mover, the OR13000 is self-propelled to work sites on a custom modular transport system. Its ultra-thick steel track base spans nearly 100 feet to spread its colossal weight across the ground. At the peak of its unmatched 130-meter mast, the OR13000 can hoist components weighing 1,300 tons, equal to over 10 blue whales. With this power, it performs precise surgeries, assembling structures other cranes can only dream of lifting. To control such unwieldy lifting at extreme heights and capacities, Liebherr engineers developed a one-of-a-kind hydraulic system with over 350 cylinders. Advanced digital controls and 12 winches symphonically choreograph its every maneuver. As projects like offshore wind farms push the boundaries of mega engineering, there is no crane better equipped to answer their mounting needs than the Liebherr OR13000. It remains the undisputed king of superlifting and heavy lifting for the most challenging of industrial endeavors. The OR13000 demonstrates how ingenuity and precision German engineering can continually defy expectations of what is possible through reliable and powerful heavy transport machines. Its name will remain synonymous with lifting the impossible. At NASA's Kennedy Space Center in Florida, two incredible machines reside that have played a vital yet unseen role in America's spacefaring history: the NASA crawler transporters. Each towering over 3 stories and spanning over 170 feet in length, the massive orange crawlers possessed the Herculean task of carrying rockets from the vehicle assembly building to launch Complex 39. Propelled by 2 independent diesel-electric powertrains, generating 7,000 horsepower each, the crawlers creaked forward at a maximum speed of just 1 mile per hour, while bearing payloads over 6 million pounds. To support their weight of over 3 million pounds, the crawlers utilized a unique articulated base with 24 independently steerable tracks. This crab-walking motion allowed them to scale slopes as steep as 5 degrees across the sandy Florida surface. For 50 years, the crawlers reliably transported Saturn V space shuttle, and now NASA's upcoming Space Launch System, on their slow yet steadfast journey to the stars above. Though soon to be retired, their legacy will forever be linked to helping place humans on the moon and beyond. As true unsung heroes of the space age, the tremendous NASA crawler transporters inspired generations with their steady fortitude, transporting the dreams of explorers atop their backs across the final miles to launch. In the remote wilds of northern Canada lies a seldom-seen machine that few would believe actually exists. Standing 40 feet tall and stretching 300 feet long, it is the biggest vehicle ever built for overland travel, the Big Muskie pipeline hauler. Constructed in the 1960s by Denny Husky International and the Canadian government, the Muskie was purposed with the Herculean task of transporting equipment to build the 1,171-mile-long CANOL pipeline project through the Yukon wilderness. Weighing in at an unbelievable 13.5 million pounds, the Muskie is self-propelled on 48 massive tires, each larger than a small car. Power comes from 4 diesel engines generating over 5,000 horsepower combined, allowing a top speed of 3 miles per hour over rugged terrain. When fully loaded, the Muskie carried an entire mobile drilling station inside its expansive hull, a fully functional worksite on tracks. Through sheer determination and engineering innovation, it succeeded in delivering vital materials where no road had ever gone before. Though the pipeline was decommissioned in the 1950s, the Big Muskie lives on today as a testament to incredible feats possible through cooperation and never-say-die northern spirit. Though roads now cross the spots it tread, the legend of this true colossus of the far north lives on. In open-pit mines across the world, enormous machines shift mountains of dirt and rock to feed our endless demand for resources. But few compare to the true titan known as the Bagger 293, the largest land vehicle ever constructed. Towering over 355 feet, with an excavating wheel wider than a football field at 170 feet, the Bagger 293 was built for the sole purpose of rapidly excavating lignite coal in Germany's Hambach surface mine. Powered by over 13,000 horsepower generated from 3 diesel engines, the Bagger's multi-ton laden shovel arm swings with mesmerizing precision. A fleet of 2-story dump trucks appear like toys as they queue for its constant outpouring payload. Removing over 1.3 billion tons of overburdened rock and earth, the Bagger has enabled mining to depths previously unattainable by traditional methods. Its advances in automation and computer controls for machines many stories tall continues pushing the very limits of engineering. While the Bagger's unprecedented scale alarms some, without such innovations our globalized civilization cannot be sustained. As mining pushes ever deeper to sustain society's growth, the true giants like 293 will remain at the cutting edge of resource extraction. Their immense feats allow our modern world to continue flourishing. Over the course of this story, we've uncovered truly astonishing machines that redefine what's possible through industrial engineering. By pushing material loads, lifting capacities, operational sizes, and overall scales far beyond normal comprehension, these Goliaths showcase humanity's relentless progress in taming natural barriers. Whether transporting rocketry across continents, mining coal from depths greater than skyscrapers, or assembling mega-projects in inhospitable terrain, each behemoth serves a purposeful role that elevates modern civilization. Their gigantic aspects that seem implausible were brought to reality through intense innovation, specialized design, and unrelenting human ingenuity. While such massive vehicles carry environmental and social impacts, their necessity to sustain our global population means their role is far from over. As long as humanity continues expanding the very limits of what we build and extract, we'll need even larger machines to take us there. The future remains unwritten in what new frontiers of engineering we may cross. But for now, we can marvel at the tremendous feats witnessed here. From the sands of Florida's Space Coast to the frozen Yukon wilderness, these true leviathans illustrate our endless drive to conquer imposing challenges through practical yet visionary applications of science and problem-solving grit. In a sense, they show not what's possible today, but what may become possible tomorrow through continuous betterment of our skills and refusal to accept hard boundaries. The largest land vehicles, it seems, have yet to be built.